Okay, lesson 18 is various mathematical models and applications, that is to say, word problems. The first problem is 3 equations and 3 unknowns. The number of blues was 4 less than the sum of the whites and the greens. Also, the number of greens equaled the sum of the blues and the whites. How many of each were there if there were twice as many blues as whites? So we're just going to write 3 equations for those 3 things. The number of blues equals 4 less than something, so we're going to subtract 4 from whatever that is, and that is the sum of the whites and the greens, so whites plus greens. Then it says also the number of greens equaled the sum of the blues and the whites, so B plus W. And then how many of each were there if there were twice as many blues as whites? That's a little tricky because sometimes you want to multiply the blues by 2, but if you think about what it means, it says there were twice as many blues as whites, which means there's more blues. So in order to get the number of blues, you have to multiply the whites by 2. Twice as many blues as whites means that the blues are twice the whites. So those are our 3 equations and 3 unknowns, and to solve this, we're just going to use substitution. So since B is 2W, I'll go ahead and put that into the second equation, and I will get G equals 2W plus W, which is 3W. And then I will take that 3W and put that in for G in this equation. So B equals W plus 3W minus 4. So B is equal to 4W minus 4, and then we'll just go back and use this again for B, put that in, 2W, so 2W is equal to 4W minus 4, so negative 2W is equal to negative 4, so W is 2, and since B is 2W, B is 4, and since G is 3W, G is 6. So we would say 2 whites, 4 blues, and 6 greens. Moving on. Okay, in this kind of problem, each quantity that we're looking for has a number, however many there are, and it also has a value. So we're going to write 2 equations. One will be about how many of the thing we have, and the second equation will be about how much those things are worth. So we have quarters, nickels, and dimes. Quarters are worth 25 cents, nickels are worth 5 cents, and dimes are worth 10 cents. It says the quarters, nickels, and dimes total 20. That means there are 20 coins. So if Q is the number of quarters, N is the number of nickels, and D is the number of dimes, then that should add up to 20 coins total. The book uses subscripted variables for these problems, but there's no reason to use subscripted variables. I think they're just trying to introduce you to subscripted variables, but it's not necessary in my opinion, so I would just call them Q, N, and D. Their value is $1.90, so now we're going to write an equation about their value. And we're not going to use decimals, we'll just use cents as numbers. We'll say 190 cents, that way we don't have to deal with all those decimals. So each quarter is worth 25 cents, so 25Q is the value, and then each nickel is worth 5, so 5N is the value of the nickels, and then each dime is worth 10, so 10D is the value of the dimes, and that should all add up to 190 cents. All right, so we only have 2 equations with 3 unknowns, but thankfully they gave us another piece of information, and that is there are 4 times as many nickels as quarters. So that means that there are more nickels, so that means that the nickels, you have to multiply the quarters by 4 to get how many nickels there are. All right, so now you have 3 equations and 3 unknowns, and first of all, we're going to substitute. For every N we see in the first 2 equations, we're going to put 4Q. So Q, the first equation, plus 4Q plus D equals 20. And then in the second equation, 25Q plus 5 times 4Q, that's 20Q, plus 10D equals 190. So now we have two equations and two unknowns. 5Q plus D equals 20, and then 45Q plus 10D equals 190. And so I'm going to multiply that first equation by -10, just so I can make the D's cancel out. So that will be negative 50Q plus 45Q is negative 5Q. And then you've got negative 10D plus 10D, that's 0. And then you've got negative 10 times 20 is negative 200, plus 190 is negative 10. So Q is 2, so there are 2 quarters. And we know that the nickels would be 4 times that, so 8 nickels. And then the dimes, we know that 5Q plus D equals 20. So that means that 10 plus D is 20, so D is going to be 10. Oops. 10 dimes. Okay, this is direct and inverse variation. It says reds varied directly as blues squared and inversely as greens. When there were 80 reds, there were 4 blues and 2 greens. How many reds were there when there were 8 blues and 10 greens? There are 2 ways to do direct and inverse variation problems. There's a 2-step process. If reds vary directly as blues, that means that the number of reds is equal to some constant K times the number of blues. And this was blues squared. Sorry about that. Reds varied directly as blues squared. So that would be how you'd set that up. And then it says, and they varied inversely as greens. So that means that reds are equal to some constant over the number of greens. So greens is in the denominator. And the first part of this 2-step process is that you find out what K is. So it says when there were 80 reds, there were 4 blues and 2 greens. So 4 blues, so 4 squared, and then greens, there were 2. And so if you multiply both sides by 2, you get 160 is equal to 16K. So K is 10. And now you go back for your second step and you plug in K to the equation you started with. So you would have R equals 10B squared over G. And now you plug in the second values they give you. How many reds were there when there were 8 blues and 10 greens? So reds equals 10 times 8 blues squared, that's 64, and 10 greens. So 10s cancel, and you get the number of reds is equal to 64. So we can also do this with a 1-step process by setting up some proportions. And we do that by saying that when 2 values are directly proportional or vary directly, we would say that R1 over R2 is equal to, in this case, it says they vary directly as blues squared. So we would say blues squared 1 over blues squared sub 2. So the first blues value over the second blues value that were given. And then they said reds vary inversely as greens. So we're going to flip the greens upside down and put the second green value on top and the first green value on the bottom. So when 2 values vary inversely, R1 over R2, in this case, would equal G2 over G1. We flip it upside down. So the 1s and the 2s here refer to the first values you're given and the second values you're given. So we're going to just fill in whatever the values are that they gave us. So they said when there were 80 reds, so that's R sub 1, the initial value for R. There were 4 blues, so that's B1, the initial value for B, so we're supposed to do squared for that. And then there were 2 greens. That's the initial value for G, and that goes on the bottom, G1. And then it says how many reds would there be, so that's our 2, we don't know. When there were 8 blues, so that's B2, we have to square it, and 10 greens, so that's G2. So we can fill all the values into one equation in this process, and then we just cross multiply. So we would have 4 squared times 10 times R2 is equal to 80 times 8 squared times 2. So I want to do some canceling here. So I can cancel the 10 with the 80, and that'll be 8 left over. And then 4 squared is 16, so I've got one of those 8s times 2 is 16, so I would have another 8 left. So R2 again is 64. Okay, this problem is about digits and place value, and the fact is we have what's called a decimal system, and what that means is that we have 10 digits, 0 through 9, but we also use them in a certain way to express their value. I mean, the digit 9, for example, has the value 9, but if it's placed next to another number, the digit 9 might have a different value. For example, if I write 92, 9, this digit right here is no longer worth 9, it's worth 90. So it's worth 9 times 10 because it's in the second position if you go from right to left. If I write this number, now the 9 is worth 9,000 or 9 times 1,000 because it is in what we call the thousandths place. So the value of the digit depends on how it is juxtaposed with other digits. So when we write numbers, their values are based, we have to think about where is that digit located in the whole number. So this is what this problem is dealing with. It's talking about a 2-digit number. So it says the sum of the digits of a 2-digit number, 2-digit counting number, is 5. When the digits are reversed, the number is 9 greater than the original number. What is the original number? So first of all, we're going to talk about the 2 digits. We've got a tens digit and we have a ones digit. We're not going to use O for the ones digit because O looks like a 0. So we're going to use the letter U for units digit. And we're going to talk about the digits themselves and then the value of the digits. So if we call T the tens digit, we mean in the original number, that is the number that would be second from the right. And then the U for units digit or ones digit. And when we talk about that, we're talking about the digit that is furthest to the right, the ones place. Okay, so they tell us that the sum of the digits is 5, right here. So T plus U, these are just the digits, their sum is 5. So this might be a number like 32 or 41, something like 50. So it's a 2-digit number whose digits add up to 5. All right, but then they're going to tell us something about the value of this number, of this 2-digit whole number, counting number. When the digits are reversed, the number is 9 greater than the original number. Okay, so that can be confusing. Let's think about the value of the original number. The digit in the tens place is T, so its value is 10 times T. And then the U is the units digit. The ones digit is just worth whatever U is. If it's a 3, it's worth 3 because that's how the ones digit is. So this is the value of the number we're looking for, of the number. But now it's telling us that the digits are reversed. All right, so this original number has the T coming first and the U second. they're saying we're going to reverse the order of the digits, which means that U is first and T is second, which means U is now in the tens place. So it's worth 10 times the value of U. So the new number we're talking about when the digits are reversed is going to be 10U plus T, because now the tens digit is now in the ones place. So it's only worth whatever that digit is. So that's the value of the number when the digits are reversed. And they're telling us that when the digits are reversed, that number right there is 9 more than the original number. And the original number has a value of 10t plus u because the t is in the tens place. So 10t plus u. So we can go ahead and solve, because 2 equations, 2 unknowns means you have enough information to solve it. So over here in this right-hand equation, we'll go ahead and get the t's and the u's on one side. So if you subtract u on both sides, well, first of all, if you subtract 10t on both sides, you're going to have negative 9t on the left. And if you subtract u on both sides, you're going to have a positive 9u. And then what's going to be left is 9 on the right side. So these are our 2 equations now. And we can solve just by multiplying the first equation by 9. So we'd have 9t minus 9t. The t's are going to cancel. Then we have 9u plus 9u. That's going to give us 18u. And then 9 times 5 is 45, plus 9 is 54. And so that means that u is going to be 3. And so if u is 3 and the digits add up to 5, then that means that t is 2. So the original number is 23. And you can see that when you reverse the digits, it becomes 32, which is 9 more than 23. So we did it right. Okay, chemical mixtures. To get 1,000 gallons of a mixture that is 56% alcohol, it was necessary to mix a quantity of 20% alcohol solution with a quantity of 80% alcohol solution. How much of each was required? Okay, first of all, whenever it says something is in solution, it usually means that there's some thing like alcohol or salt or ammonia or something like that that has been dissolved in water or some other thing. So that's what a solution is. It's a mixture that has a certain percentage of some chemical that we're interested in. In this case, that is alcohol, and all the rest of what's in that solution is just other stuff, usually some kind of solvent. Okay, so it says here that we have a solution that is 20% alcohol. We have another solution that's 80% alcohol, and we want to create a 56% alcohol solution. So we're going to pour some of the 20% into a bucket, and we're going to pour some of the 80% into a bucket. And we're going to pour X gallons of this stuff, and we're going to pour Y gallons of this stuff. And we want to end up with 1,000 gallons. So first of all, we're going to write an equation that's just about gallons of a mixture. It doesn't really have anything to do with, we're not talking about the alcohol specifically right now. We're just talking about gallons of stuff. So we're going to pour in X gallons and Y more gallons, and we're going to get a total of 1,000 gallons. Okay, now we're going to write an equation about just the alcohol that's going into that bucket. All right, so when I dump in stuff from the yellow bucket, 20% of that is alcohol. So the first thing in this equation is 0.2 of those gallons. 0.2 times X gallons, that is all alcohol. And then the second bucket, the stuff I'm pouring out of the blue bucket, 80% of that is alcohol. So 0.8 of those gallons are alcohol. And then I want to end up with a 56% solution. So I want it to be that 0.56 of these 1,000 gallons are alcohol. So we wrote an equation about gallons of mixture, and then we wrote another equation that's just about the alcohol. All right, so now we have 2 equations and 2 unknowns. And to solve this, I would first of all like to multiply that second equation by 100 to get rid of the decimals. So our first equation, x plus y equals 1,000. Second equation, 20x plus 80y is equal to 56 times 1,000, so 56,000. And then we can multiply the first equation by negative 20, and that'll make the x's cancel, and we'll have negative 20y plus 80y is 60y. And then we'll have negative 20,000 plus 56,000 is 36,000. So y is going to be 600 gallons. So 600 gallons of the 80% solution, and then x is going to be the rest, which is 1,000 minus 600, which is 400 gallons of the 20% solution. Okay, and now we have another kind of application that we use proportions to solve, where you're talking about some kind of chemical compound and the atomic weights of the atoms in that compound, and how each different kind of molecule and how each different kind of element is a certain percentage of the total weight of whatever that compound is. Okay, so in these problems, they give you the compound or the molecule, and they tell you how many atoms of each kind of thing are in there. So this has 3 atoms of carbon, 7 of hydrogen, and 1 of chlorine. And then they give you the atomic weights for each element in that compound. They tell us that the weight of the carbon in the container of this molecule is 113 grams, and they want to know what the total weight of the compound is. So the proportion we're going to be setting up is the amount of carbon over the total. We want to find out what the total weight is if we know the weight of the carbon, which is 113 grams. So 113 for the carbon, and then we're looking for total. Okay, so to figure that out, we need to know what is the proportion of carbon to total in weight for each molecule. All right, so they tell us that carbon has an atomic weight of 12. So let's just look at the molecule. So we've got 3 atoms of carbon. So that's going to be 3 times 12 for 36. And then we have 7 atoms of hydrogen. So that's going to be 7 times the weight of hydrogen, which is 1. And that'll be 7. And then we have 1 atom of chlorine. And that weighs 35. So that's going to be 35 times 1, which is 35. So the total atomic weight of the molecule is going to be 78. So each molecule is 78, and the carbon is 36 of that 78. So the ratio of carbon to total is 36, so 3 carbon atoms over the total, which is 78. And we are told that we have 113 grams of carbon, and we're trying to figure out what the total weight in that container of this molecule, this compound, would be. So now we can cross multiply. So cross multiply, 36T is equal to 78 times 113. And if you punch that into your calculator, you are going to get that T is about 244.83 grams.